All right, so we've been beginning the chapter with electron configurations, and we'll go over this more in class and I'll answer whatever questions you guys have tomorrow. This is just, we're going to add one small piece today, and again, we'll go over whatever questions you guys have tomorrow. So when we're doing valence electrons, our electrons are the particle that are responsible for forming compounds. So if you remember, or other molecules. So if you remember from chapter 3, when we're talking about matter, a molecule is anything that is made up of two or more elements. So for example, we have like hydrogen is a molecule, it's an element in a molecule, and then H2O would be a compound and a molecule. So in order for these things to bond to one another, so for this hydrogen to bond to another hydrogen, and then this oxygen to bond to the hydrogens, they need to use what are called their valence electrons. And their valence electrons are the electrons that are in the highest energy level. And so these are the ones that are on the outer shells. And these are going to be the ones that are used for bonding. So they are going to share these, or they are going to gain and lose these, since these electrons are the ones that are on the outside energy level. Okay, so again, these are the ones that are the outside electrons, so the ones on the outside, and they are going to be used for bonding. These are the ones that they can gain, lose, and share. So to determine how many valence electrons we have, we first have to write the electron configuration of our element. That way we can determine how many electrons they have at the highest energy level. So we're going to write it for magnesium. So we'll go and find magnesium on here. And if we see here, well, magnesium is 12, so that means that there are 12 protons, which also means that there are 12 electrons if we're talking about an atom, which we are. So again, we're always going to start at the beginning. So we're going to start with our first electron. And our first electron is found in our first energy level, because we always feel it closest to the nucleus outwards. So we have 1, and then we're in the S blocks. If you remember, these purple right here are the S. These red over here are the P. These yellow are the D, and then down here are the F groups. So we have 1 S, and then we have electron number 1 and electron number 2. So we would have 1s2, which makes sense because our first energy level, if you remember from a while ago, our first energy level can hold 2 electrons. So we know that our first energy level is filled. So we go now to electron number 3. The electron number 3 is going to be found in the second energy level. It's still going to be found in the S block, and then electron 3 and 4 are going to take up the S block. The S block can only hold 2 electrons, so now we keep going, we run into electron 5. We're still in our second energy level, but now we're in the P block, and now we're going to have 1, 2, 3, 4, 5, 6 electrons. Okay, we're now at electron 11, so nothing to the right of neon, come back, electron 11. Okay, well, our second energy level can only hold 8 electrons. If we look, we have 2 plus 6, so our second energy level currently has 8 electrons. So now we're going to come to electron 11. We're going to write 3. We're now in the sublevel S, and then we have electron 1, electron 2, so 3s2. So this would be our electron configuration. So 1s2, 2s2, 2p6, and 3s2. So if you remember, this large number out front, these represent our energy levels. Well, the valence electrons are the electrons in the highest energy level. The exponent right here, these represent our electrons. So we're going to find our energy level that's the highest. So we have 1, we have 2s, and we have 3s. Well, our 3 is the highest energy level. So we only care about electrons in the third energy level. There are only 2 electrons in the third energy level, so that means that magnesium is going to have 2 valence electrons. And the symbol for valence electrons we're going to use, just abbreviated, is Ve. Okay, and so the when magnesium forms a compound, it's going to lose 2 electrons in order to form an octet, which we'll talk about later when we get to talking about ions. Okay, so now we'll try for Si. Okay, so we're going to do for silicon. So if we go here, silicon has 14 electrons. So we're going to start always at the beginning. So we have 1s2, because electron 1, electron 2. Come to electron 3. We're at the second energy level, so that's 2s2. So electron 3 and 4. Now we run and we find electron 5, which is 2. But now we're in the p block, and we have 1, 2, 3, 4, 5, 6. Run out, come back to the beginning, and we have 3 back at the S sublevel. We have 1, 2. Keep reading. Now we're at 2. Oh, I'm sorry. We're at 3 because aluminum's 3. But now we're in the P block, and we have 1, 2 electrons. So if we add all exponents up, we want to make sure that they add to 14. So 2, 4 plus 6 is 10, plus 2 is 14. So we know that we've used 14 electrons, which is good. So now in order to determine the valence electrons, we care about the electrons in the highest energy level. So we have electron energy level 1, 2, 2, 3, 3. Well, the highest out of those numbers is 3, so we only care about the electrons that are in the third energy level. So if you remember, the exponents tell us the electrons. So we have 2 plus 2. So we have 4 valence electrons. So that is how we find our valence electrons. We look at the highest energy level. And we will try one tomorrow in class where we talk about having the D block examples. But for right now, that's all you need to know about valence electrons.